Okay, in this video, I'm going to talk about section 5.4 dealing with systems of nonlinear equations in two variables. And out of this section, we're going to recognize systems of nonlinear equations in two variables, solve nonlinear systems by substitution, and solve nonlinear systems by addition. Okay. Now, probably in your other classes, you might have talked about systems of equations in two variables, and they were both linear equations. Now, this time, we're going to look at nonlinear systems. Okay, a nonlinear system or a system of linear equations in two variables contain at least one equation that cannot be expressed in this standard form for a linear equation. Ax plus by is equal to c. That's standard form for a linear equation. And a couple of examples that I have here are this. X squared is equal to 2y plus 10, and 3x minus y is equal to 9. Now, while the second equation is a linear equation, is of the form ax plus by is equal to c, that first equation is not because of the x squared. And then the second one, we got y equal x squared plus 3, and x squared plus y squared is equal to 9. That's an example of a system of equations that are non-linear. Because y is equal to x squared plus 3, that's actually the graph of a parabola. And x squared plus y squared is equal to 9. That's actually the graph of a circle. So those two are non-linear equations. Okay, it could be one equation that's nonlinear, or it could be both equations that are nonlinear. Now, a solution of a nonlinear system in two variables is an ordered pair of real numbers that satisfies both equations in the system. Now, the solution set, of course, is the system is the set of all such ordered pairs. And as with linear systems in two variables, the solution of a nonlinear system, if there is one, corresponds to the intersection points of the graphs of the equations in the system. So actually, you're going to find the points that intersect those two graphs. All right, here we're going to start by eliminating a variable using what they call the substitution method. And that's this. The substitution method involves converting a nonlinear system into one equation and one variable by an appropriate substitution. The steps in the solution process are exactly the same as those used to solve a linear system by substitution. Now, the difference here is this: when you obtain an equation in one variable, that equation may not be linear. So if we look at example 1, here I would like to solve by the substitution method. And here we got x plus y is equal to 3, and y is equal to x squared minus 17. Now, the way I want to do this is write those two equations side by side. So I write x plus y is equal to 3 here, and on this side I'll do y is equal to x squared minus 17. Now, as you can see here, I have a variable by itself. Here y is equal to x squared minus 17. So here I can go ahead and do the substitution, and I'll do that. Well, since y is equal to x squared minus 17, I'll take this x squared minus 17 and substitute it for this x in the other equation. For the y in the other equation, I'm sorry, because y is equal to that, but I want to substitute for this y right here. That way I will have an equation in one variable, but it doesn't have to be linear. It's not going to be linear in this case. Excuse me. So I'm going to bring down the x, and then plus this y will be substituted with the x squared minus 17, because that's what y is equal to. And that's going to be equal to 3. What I'm going to do here is write my terms in descending powers here. In other words, I'm going to put the x squared in front, and then plus x minus 17 is equal to 3. Now notice I have a quadratic equation, but to solve the quadratic equation, I need to get a 0 on one side of this equation. That means I need to move that 3 over to where x squared plus x minus 17 is, and I'll do that by subtracting 3 on both sides. So that means x squared plus x minus 20 will be equal to 0. Now that x squared plus x minus 20, I can factor that into two binomials here. So I'm going to break x squared up as x times x, and I need factors of negative 20 that will give me 1x as a middle term. Well, I know 5 and 4 would do that. But since the middle term is a plus and the last term is a minus, I have to have different signs here. And the larger of the two factors takes the sign of the middle term. 5 is larger and the middle term is plus, so that means the 5 needs to be a plus, the 4 has to have the minus sign there. So factored completely, I get x plus 5 times x minus 4 is equal to 0. And then I'll set each binomial factor equal to 0. So this means x plus 5 is equal to 0, excuse me, and x minus 4 is equal to 0. And then for each equation, I'll solve for x. So for the x plus 5 equal to 0, if I subtract 5, I get x is equal to negative 5. And then for the x minus 4 equals 0, if I add 4, you'll get x is equal to 4. So I get two x values here. Each one of them I'm going to find out what y is. I got x equal negative 5 and x is equal to 4. So for each x, I'm going to find out what y is. So let's start off with x is equal to negative 5 and find out what that y value is. Okay, because I know that this equation is going to cross, this system is going to intersect at two different points. And I can use either one of these equations to find out what y is. I'm going to use the easier one, like x plus y is equal to 3. And then substitute my x with that negative 5. So I got negative 5 plus y is equal to 3. And to get y by itself, I have negative 5, so I need to add 5 to both sides. So that means y is equal to 3 plus 5, which is 8. So one ordered pair would be when x is negative 5, y is 8. And let's find out what my other ordered pair is when I have x equal to 4. And I'll still use x plus y equals 3. That's one of my two equations. And substitute the x with 4. So it'd be 4 plus y is equal to 3. And to solve for y, we subtract 4 to get y is equal to 3 minus 4 is negative 1. So when x is 4, my y coordinate would be negative 1. So these are my two ordered pairs that will satisfy this nonlinear system of equations. Negative 5, 8, and 4, negative 1. Okay. All right, now let's look at example 2. Say we got this. We want to solve by the substitution method. Here we got x plus y is equal to 2 and y is equal to x squared minus 8x plus 14. And I'm going to write these two equations side by side. X plus y is equal to 2 and y is equal to x squared minus 8x plus 14. Well, again, I got y equal to something. And in this case, y is equal to x squared minus 8x plus 14. So what I'm going to do there is take that x squared minus 8x plus 14 and substitute it for this y in the other equation, where I got x plus y equal 2. That y will be replaced with this x squared minus 8x plus 14. So here I'm going to have x plus the y. I'll substitute that with x squared minus 8x plus 14, and then that's equal to 2. So now I have an equation in a single variable. Now I'm going to go ahead and combine like terms on the left-hand side. I'll bring down the x squared first because I want this in descending powers. 1x minus 8x will be a minus 7x plus 14, and that's equal to 2. Now, again, I have a quadratic equation where I can get a 0 on one side. So let's move that 2 over to where x squared minus 7x plus 14 is by subtracting 2 on both sides. When I do that, I got x squared minus 7x. 14 minus 2 would be plus 12. And that's equal to 0. Okay. Now that x squared minus 7x plus 12, let's try to factor that into two binomials here. That x squared breaks up as x and x. And the factors of 12, that gives me negative 7x, where they have to be negative here, or both minus signs. The only two numbers that would do that would be 4 and 3, because 4 times 3 is 12. Minus 4x and a minus 3x will give me the minus 7x. So x minus 4 times x minus 3 will be equal to 0. And then I'll set each binomial factor equal to 0. So this means that x minus 4 is equal to 0. X minus 3 will be equal to 0. And then we'll solve each equation for x. So for the x minus 4 equals 0, if I add 4, you'll get x is equal to 4. And for x minus 3 equals 0, if I add 3, you'll get x is equal to 3. So those are my two x values for this nonlinear system. X equals 4 and x is equal to 3. Now for each one of those, I need to find out what y is, what their y coordinates are. Let's start off with the x is equal to 4. And I'm going to pick the easiest one to work with, which is that x plus y is equal to 2. Substitute your x with 4 in that equation, you'll get 4 plus y is equal to 2. And if I subtract 4 on both sides to solve for y, that means y will be equal to negative 2. So in this case here, when x is 4, my y coordinate would be negative 2. So I have one ordered pair for negative 2. And then for x is equal to 3, I'll still use that x plus y is equal to 2 and substitute my x with 3. So it'll be 3 plus y is equal to 2. Subtract 3 on both sides, you'll get y is equal to negative 1. So when x is 3, y will be equal to negative 1. So here's the other ordered pair that will satisfy this system of nonlinear equations. So my two ordered pairs will be 4, negative 2, and 3, negative 1. Okay. Here's another example where we use the substitution method to solve the system of equations here. Here we got x squared plus y squared is equal to 202, and x minus y is equal to 2. Let's see. Let me write the x squared plus y squared is equal to 202 first, and then x minus y is equal to 2 here. What I'm going to try to do is get x by itself, and then do the substitution here. So here, to get x by itself, I'm subtracting y. Let's go ahead and add y to both sides. So that means x is equal to, and it'll just be y plus 2. X is equal to y plus 2. Now, the next thing I'm going to do here is do my substitution here. Since x is equal to y plus 2, I'll take that y plus 2 and substitute it for this x in the other equation. So I'll have an equation in a single variable. So this x is being replaced with the y plus 2, and that's going to be squared, plus y squared is equal to 202. All right, now I need to simplify that y plus 2 quantity squared. Here's what I'm going to do off to the side here. I can do that over here. Y plus 2 is used as a factor twice, so I'll just write that as y plus 2 times y plus 2. And use the FOIL method for this. First times the first, y times y, that's y squared. Outer, y times the plus 2 would be plus 2y. Inner, 2 times y would be plus 2y again. And then the last times the last, 2 times 2 would be plus 4. So if I combine like terms, I have y squared plus 2y plus 2y, that's 4y, then plus 4. So y plus 2 quantity squared would be y squared plus 4y plus 4. So I'll go ahead and write that in. And then bring down the plus y squared, that's equal to 202. And if I combine like terms here, 1y plus another 1y would be 2y squared. 1y squared plus another y squared would be 2y squared. Plus 4y plus 4 is equal to 202. Now I need to get a 0 on one side of this equation since it's a quadratic equation that I have here that I'm trying to solve for. So let's move the 202 over to where the other terms are by subtracting 202 on both sides. So that means I have 2y squared plus 4y, and now 4 minus 202 will be negative 198, and that's equal to 0. Now let's see if we can factor this out completely, because notice I do have a common factor that's in 2y squared, 4y, and negative 198, and that's going to be 2. So if I factor out the 2, this means 2y squared divided by 2 will be y squared, plus 4y divided by 2, that would be 2y, minus 198 divided by 2, that would be 99, and that's equal to 0. And let's try to factor y squared plus 2y minus 99 into 2 binomials here. Let's see, y squared breaks up as y and y. The middle term is a plus, the last term is a minus, so one has to be plus, the other one has to be minus. The only factors of 99 that I can think of that would give me 2y as a middle term would have to be 11 and 9. Okay, 11 and 9. Because if you run down the factors of 99, that'd be 1 and 99. 2 won't go in there evenly. 3 and 33. 4, 5, 6, 7, and 8 would not go into 99 evenly, but 9 will 11 times. So we have to use 9 and 11. But the middle term is plus. So the larger of those two factors will have to take the sign of the middle term. So the 11 needs to be plus, the 9 needs to be minus. So it'll be 2 times the quantity y plus 11 times y minus 9 is equal to 0. And then we set each factor equal to 0. So this means 2 is equal to 0, y plus 11 is equal to 0, y minus 9 is equal to 0. Well, 2 equaling to 0 is a false statement. We can eliminate that. For y plus 11 is equal to 0, if I subtract 11, that means y is equal to negative 11. And then for the y minus 9 equal to 0, if I add 9, you'll get y is equal to 9. So these are two y values here. y equal -11, and y is equal to 9. And for each y value, I will find out what x is. So let's start off with the y equal -11. Well, notice I got x is equal to y plus 2. Let's use that to find out what each x value will be. So let me bring down the x is equal to y plus 2. Substitute the y with -11, so -11 plus 2 gives us an x value of -9. So one of my ordered pairs, and I have to put x first and then y. -9, 11. -9, -11, I'm sorry. And then for y equal 9, I'll still use that x plus y is equal, x equals y plus 2. X is equal to y plus 2. That comes from here. And then replace the y with the 9, so 9 plus 2 will give us an x value of 11. So my other ordered pair that will satisfy that nonlinear system would be 11, 9. So those are the two ordered pairs that will satisfy this nonlinear system: -9, -11, and 11, 9. Okay. Okay, example 4 on the next page. Oops. Here's example 4. Here we got x plus y is equal to -8, and x plus 4 quantity squared plus y plus 9 quantity squared is equal to 17. And here I want to solve this system of equations by substitution. So in this case here, let's deal with the x plus y is equal to -8. And I'm going to go ahead and get y by itself by subtracting x on both sides. So that means I'm going to have y is equal to -8 minus x. -8 minus x. And then this other equation, x plus 4 quantity squared plus y plus 9 quantity squared is equal to 17. Which is, by the way, if you don't know, it's the equation of a circle. And here's what y is equal to: -8 minus x. So I'm going to take that and substitute it for this y in the other equation. So here I'm going to bring down x plus 4 quantity squared, and then the y will be substituted with -8 minus x, and then bring down the plus 9, and all that's going to be squared is equal to 17. Now, if I bring down the x plus 4 quantity squared, simplify what's in this parentheses here, -8 plus 9, that's going to be 1. So I have 1 minus x quantity squared is equal to 17. For this, I'm going to have to use the FOIL method, and for this one, I also have to use the FOIL method. So if I do the x plus 4 quantity squared off to the side, I know that's going to break up as x plus 4 times x plus 4, and then I can use the FOIL method, since x plus 4 is used as a factor twice. So here, x times x, that's x squared, outer, x times the plus 4 will be plus 4x. The inner, 4 times x would be plus 4x. Last times last, 4 times 4 would be plus 16. So here I got x squared, 4x and 4x will be 8x, and then plus 16. So that's what x plus 4 quantity squared will be. So I'll write in the x squared plus 8x plus 16. And then for the 1 minus x quantity squared, I can write that as 1 minus x times 1 minus x, and again use the for method like I did before. So here 1 times x will be 1 times 1 will be 1. The outer 1 times the minus x will be minus 1x. Minus x times the 1 will be minus 1x. And then minus x times the minus x will be plus x squared. And then combine like terms to bring down the 1. Minus 1x and a minus 1x will be minus 2x plus x squared. So I have 1 minus 2x plus x squared, which is what 1 minus x quantity squared is. So I'll write that in. And then that's equal to 17. Now, when I combine like terms here, 1x squared plus another 1x squared, that's 2x squared. 8x minus 2x would be a plus 6x. 16 minus 1 would be a plus 17. So I got 2x squared plus 6x plus 17 equals to 17. Now I have a quadratic equation, which means I need to get a 0 on one side in order to solve it. So to do that, I'll need to subtract 17 on both sides, which means 2x squared plus 6x will be equal to 0. Now let's do some factoring on the left-hand side here. For that 2x squared plus 6x, let's see if I can factor out the 2x. So if I factor out that 2x squared divided by 2x would just be x, plus 6x divided by 2x would be 3. So I got 2x times the quantity x plus 3 is equal to 0. Then I'll set each factor equal to 0. So that means 2x is equal to 0. X plus 3 will be equal to 0. And then we solve each equation for x. So for the 2x equal to 0, that would have to mean x is equal to 0. And then for the x plus 3 equals 0, if I subtract 3, x will be equal to negative 3. So these are my two x values for each of those x coordinates, x equals 0 and x equals negative 3. Now we're going to find out what each y coordinate would be, starting with x equals 0. Let's go ahead and use that y equals negative 8 minus x, since I've already got that equation solved for y. And substitute 0 in for x. So that means y is equal to negative 8 minus x, which is 0. And negative 8 minus 0 will be negative 8. So when x is 0, y will be negative 8. I'll go ahead and put that there. Now the other one, x equal negative 3. And I'll still use the y is equal to negative 8 minus x. So in this case here, replace the x with negative 3. I have y equal negative 8 minus a negative 3. And if you do negative 8 minus a negative 3, you'll end up with negative 5. So when x is negative 3, my y value will be negative 5. And these are the two ordered pairs that will satisfy this nonlinear system of equations here. 0, negative 8, negative 3, 5. Okay. All right, next we'll look at how to eliminate a variable using the addition method. How to eliminate a variable using the addition method. For nonlinear systems, the addition method can be used when each equation is in the form ax squared plus by squared is equal to c. If necessary, we will multiply either equation or both equations by appropriate numbers so that the coefficients of x squared or y squared will have a sum of 0. We then add the equations, and that sum will be an equation in a single variable. Okay, so it's somewhat similar to solving a system of linear equations using the addition method, because you want to multiply one equation or it may be both equations in order to eliminate one of those variables. Same is true for the nonlinear systems of equations. All right, so on the next page, we have an example just like that. Let's say I want to solve the system by the addition method. Here we got x squared plus y squared is equal to 106, and x squared plus y squared is equal to negative 56. And here I want to solve that system of equations here. And I'll even go ahead and rewrite these two equations here. Excuse me. Now, as you can see here, we can go ahead and add these equations directly, because notice I have a plus y squared and a minus y squared. I already have opposite signs. So we can add these two equations together. X squared plus another x squared is 2x squared, plus y squared and a minus y squared, that adds to 0, so that's gone. And then that's equal to 106 plus negative 56 will just be 50. So I got 2x squared is equal to 50. And to get x squared by itself, I'm going to divide both sides of that equation by 2. So x squared will be equal to 25. Now, the opposite of squaring something would be to take the square root on both sides. So to solve for x, we have to take the square root on both sides. And if we do that, we must include the plus or minus symbol. Don't forget that. You have to include that plus or minus symbol anytime you take the square root on both sides of an equation. Square root of x squared ends up being x, and that's equal to plus or minus the square root of 25 is 5. So here x squared is equal to plus or minus 5. And I'll write this separately as x is equal to 5 and x is equal to negative 5. And for each of those x values, we're going to find out what y is. So let's start off with that x is equal to 5. Find out what that y value will be. And I will use the first equation. Doesn't matter which one you use. You want to use the one that's easier for you to work with. And in this case, I'm dealing with the x squared plus y squared is equal to 106 because it's all plus signs, all positive. And substitute your x with 5. So we got 5 squared plus y squared is equal to 106. Square the 5, you'll get 25. Plus y squared is equal to 106. And then to get y squared by itself, you want to subtract 25 on both sides. That would make y squared equal to 81. And to solve for y, the opposite of squaring something would be to take the square root on both sides and include that plus or minus symbol. So the square root of y squared will be y, and that's equal to plus or minus the square root of 81 is 9. So we got two y coordinates for x equal 5. One will be 5 and positive 9. The other one will be 5, negative 9. All right, so now let's find out what our other ordered pairs would be after replacing the x with negative 5. And I'm still going to use the x squared plus y squared equal 106. This time I'm substituting the x with negative 5, so it'll be negative 5 squared plus y squared is equal to 106. Now, excuse me, notice when you square negative 5, that's negative 5 times negative 5, that's 25, plus y squared is equal to 106. which is the same thing here when I replace the x with positive 5. I'm going to end up getting the same y value here. And I'll verify that by just subtracting 25. On both sides, you'll get y squared is equal to 81. Square root both sides and include the plus or minus symbol. You'll get y is equal to plus or minus 9. So now for negative 5, I get two y values here. One will be positive 9, and the other one would be negative 9. And these are my 4 ordered pairs for this nonlinear system of equations. 5, 9, 5, negative 9, negative 5, 9, negative 5, negative 9. Okay. All right, now example 6. Example 6. Let's say we want to use the addition method to solve this system of equations here. We got 2x squared minus 3y squared is equal to negative 19, and 3x squared plus 2y squared is equal to 30. Now we're going to use the addition method on here. But notice, let's see what we can eliminate. Let's try to eliminate the y squared because I've already got opposite signs here, so let's try to do that. We're going to have to multiply both equations by some appropriate number here. And I'm going to do this by looking at these coefficients on the y squared, the 3 and the 2. I want a least common multiple of 3 and 2. It will have to be 6, because that's the smallest number that's divisible by 3 and divisible by 2. So I'm going to use 6 as the least common multiple. Now for the first equation, if I want that minus 3y squared to be minus 6y squared, I need to multiply that first equation by 2. Now for the second equation, 3x squared plus 2y squared is equal to 30. If I want that 2y squared to be 6y squared, I need to multiply that equation by 3. All right, so now if I simplify all of this, the top equation would be multiplied by 2. So 2 times 2x squared would be 4x squared. And then 2 times the minus 3y squared would be minus 6y squared equals 2 times negative 19 would be negative 38. And now for the second equation will be multiplied by 3. So 3 times 3x squared would be 9x squared. 3 times the 2y squared would be a plus 6y squared, equaling to 3 times 30. That's 90. And now let's add those two equations together. The 4x squared plus 9x squared would be 13x squared, minus 6y squared and plus 6y squared, that's gone. That adds to 0. And then that's equal to 38, negative 38 plus 90 would be 52. So I got 13x squared is equal to 52. Now to get x squared by itself, I need to divide both sides by 13. So that means x squared is equal to 4. And to get x by itself, I need to take the square root on both sides and include that plus or minus symbol. So that means x would be equal to plus or minus 2. Now I'm going to go ahead and write this as x equals 2 and x is equal to negative 2. Those are my x coordinates of the ordered pairs that satisfy this nonlinear system. And then next I'm going to take either the first or the second equation, substitute my x with negative 2 and x with 2. Let's start off with x is equal to 2. And I'm going to use that second equation, 3x squared plus 2y squared is equal to 30. Replace the x with 2, so it'll be 3 times 2, and that's squared, plus 2y squared is equal to 30. Now, if I square this 2, that's 2 times 2, which is the 4. 4 times the 3 in front would be 12. So I got 12 plus 2y squared is equal to 30. And then to get the 2y squared by itself, I need to subtract 12 on both sides. So 2y squared is equal to 18. Divide both sides by 2. You'll get y squared is equal to 9. And then I take the square root on both sides and include the plus or minus symbol. Don't forget to put that in. So it'll be y is equal to plus or minus 3. So when x is 2, I got two y values. One will be positive 3, and the other one will be negative 3. So I got 2, 3, and 2, negative 3. How about for x equal negative 2? And I'm still going to use the 3x squared plus 2y squared equals to 30. And replace the x with negative 2, so it'll be 3 times negative 2, and that's squared, plus 2y squared is equal to 30. Well, if I square that negative 2, that's going to be positive 4, times the 3 in front will be 12, plus 2y squared is equal to 30. And that's exactly the same thing I got right here. So if I go through all of this, I'm going to end up getting y to be equal to plus or minus 3. So when x is negative 2, I also have two y values here. One would be positive 3, and the other one will be negative 3. So here I got 4 ordered pairs that satisfy this nonlinear system. 2, 3, 2, negative 3, negative 2, 3, and negative 2, negative 3. Okay. All right, got 2 more in this video. Example 7 is this. Let's say I want to solve the nonlinear system of equations for real solution, and it did not say which method to use. Okay, here I got x squared plus y squared is equal to 4, and x squared plus the quantity y plus 1 quantity squared is equal to 9. And I want to solve this system of nonlinear equations. I'm just rewriting this. And by looking at this, let's eliminate the x squared by using the addition method. Okay. Because I got x squared and x squared. Let's go ahead and eliminate those x squares. One has to be positive, the other one has to be negative. And guess what? I'm going to let the first equation be negative for the x squared. And I'm going to do that by multiplying that first equation by negative 1. Be best to do it that way. And when I do, negative 1 times x squared would be negative x squared. Negative 1 times the y squared would be minus y squared. That's equal to negative 1 times 4 would be negative 4. And I'm going to go ahead and bring over the x squared plus y plus 1 quantity squared is equal to 9. And add these two equations together. So you can see that minus x squared and plus x squared, that's gone. Now here's what I'm going to be left with. I'm going to bring down this y plus 1 quantity squared. I'm going to put that in front. And then the minus y is equal to negative 4 plus 9 would be 5. And that y plus 1 quantity squared, I'm going to go ahead and multiply that out using the FOIL method. So that y plus 1 quantity squared, that y plus 1 is used as a factor 2 times. I'll write that out twice and use the FOIL method. So here y times y would be y squared. The outer y times a plus 1 would be plus 1y. Inner 1 times a y would be another plus 1y, and then plus last times last. 1 times 1 will be 1. So I'm going to end up with y squared plus 2y plus 1, which is what y plus 1 quantity squared is going to be. So I'll write that in, y squared plus 2y plus 1, and then bring down the y minus y squared. Okay, that's from up here. Y plus 1 quantity squared, and then minus y squared is equal to 5. Apologize for that. And this is going to work out real good because the y squared and the minus y squared gives me 0, so that's gone. The only thing will be left on the left side would be 2y plus 1 is equal to 5. And then to solve for y, I first subtract 1 on both sides, meaning that 2y is equal to 4. Divide both sides by 2. Y is equal to 2. All right, so now I need to find out what x is. I got y. I need to find out what x is. So let's see here. For y equal 2, I'll use that first equation. That's easier to work with. X squared plus y squared is equal to 4. And then replace the y with the 2. So it'll be x squared plus y is 2, so it'll be 2 squared is equal to 4. And if you square the 2, you'll get 4. So it'll be x squared plus 4 is equal to 4. Subtract 4 on both sides. X squared is equal to 0. And the only number that's squared that would give you 0 is 0. So now my ordered pair, I know what that is. I only got one ordered pair, 0 and 2. 0, 2. That would be the only ordered pair that would satisfy this nonlinear system of equations. Okay. And finally, example number 8. Now, here we're going to use the method of our choice to solve this system of equations. X squared plus 2y squared is equal to 144, and x plus y is equal to 12. Okay, so here x squared plus 2y squared is equal to 144. Now this other equation is a linear equation, x plus y is equal to 12. So trying to use the addition method would not help. It's best to use the substitution method. So here I'm going to try to get a variable by itself, either the x or the y. And here I chose the y. I chose to solve for y, and I'm going to do that by subtracting x on both sides. So here this will be y is equal to 12 minus x. And now I'm going to take that y equal 12 minus x. Well, the 12 minus x is what y is. I'll just substitute it for this y in that first equation to get an equation in a single variable. So I have x squared plus 2 times that y is going to be replaced with the 12 minus x, and that 12 minus x will be squared, and that's equal to 144. Now that 12 minus x quantity squared, I need to multiply that out first, and then whatever I get for that, it will be multiplied by 2. So off to the side, I'll do 12 minus x, and that's squared, and write that as 12 minus x times 12 minus x, and use the FOIL method. So 12 times 12, that's going to be 144. The outer 12 times the minus x will be minus 12x, inside minus 12 times, minus x times 12 will be minus 12x. And then the last times the last, minus x times a minus x will be plus x squared. And then combine like terms, this will be 144. Minus 12x and a minus 12x will be minus 24x plus x squared. So that's what 12 minus x quantity squared will be. 144 minus 24x plus x squared. Then bring down the equals 144. But this is going to be multiplied by the 2 in front. So I'm going to distribute, bring this x squared down, distribute the 2 over the 144 minus 24x plus x squared. You will get this. 2 times 144, that's 288. Minus 2 times the 24x will be 48x. 2 times the x squared will be a plus 2x squared. And that's equal to 144. Now let's go ahead and combine some terms here if we can. That 1x squared and that 2x squared will be 3x squared. I'll write this in descending powers, minus 48x, and then plus 288 is equal to 144. And as you can see, we do have a quadratic equation. So I need to get a 0 on one side of this equation by moving the 144 over to the left side. And I have to do that by subtracting 144 on both sides. So that means I got 3x squared minus 48x. 288 minus 144 would be plus 144, and that's equal to 0. And then next we're going to factor this out completely. There is a common factor in 3x squared minus 48x plus 144. That happens to be 3. So I'm going to factor out the 3. 3x squared divided by 3 will be x squared minus 48x divided by 3. That's going to be 16x. 144 divided by 3 would be 48 plus 48. And that's equal to 0. Bring the 3 down, and let's see if we can factor out that minus x squared minus 16x plus 48 into 2 binomials. X squared breaks up as x and x. Factors of 48, that would give me a negative 16 as a middle term. If this helps, you can list all the factors of 48. 1 and 48, 2 and 24, 3 and 16, 4 and 12 would work. Because negative 4x or negative 12x will give me negative 16x. So I'm going to use minus 4 and minus 12. So I get 3 times the quantity x minus 4 times x minus 12 equal to 0. And then I'm going to set each factor equal to 0. So this means 3 is equal to 0, x minus 4 equals 0, x minus 12 equals 0. Well, we can eliminate that 3 equals 0. That's a false statement. But for x minus 4 equaling to 0, if I add 4, you'll get x is equal to 4. And then for the x minus 12 equal to 0, if I add 12, you'll get x is equal to 12. Now let's find out what our y coordinates are going to be for each of these x values here. Let's start off with the x is equal to 4. And this, I'm going to use the y equal 12 minus x. Because I've already got that equation solved for y, so I'll use y equal 12 minus x. Replace the x with 4, you'll get y equal 12 minus 4, and 12 minus 4 is 8. So one ordered pair that satisfies this nonlinear system would be when x is 4, the y value came out to be 8. So I got 4, 8 as one ordered pair. And then my x equals 12. That's going to be easy because I can still use that y equal 12 minus x. Replace the x with 12, so I get y equal 12 minus 12. And 12 minus 12 ends up being 0. So when x is 12, y is going to be equal to 0. So that's the other ordered pair for this nonlinear system. So these are my two ordered pairs that satisfy this nonlinear system of equations here, 4, 8 and 12, 0. Okay. All right, so that does conclude this video on section 5.4, dealing with solving a system of nonlinear equations in two variables. Feel free to reach out to me if you have any questions about any of the problems that were discussed in this video or the homework in my math lab.